Yes, ma'am, please.
Yeah. What worries you masters you. A very good afternoon to one and all. I, Dr. Reena Meshram, on behalf of Postgraduate Department of Chemistry and IQSC Nabira Mahavidyalaya Katol, welcome you all on the third day of 10-day lecture series of late Shri Bhikkulal Nabiraji. Dear all, on this beautiful day, we have a fortunate to have Dr. Atul Nagpure sir with us. He is going to deliver a talk on a research methodology for new researchers. Welcome you, sir. Now, I want to request Dr. Nilesh Gandhare, convener and assistant professor, Department of Chemistry, Nabira Mahavidyalaya Katol, to introduce our guest of the day. Over to you, sir. Please.
Thank you, ma'am. Good afternoon, one and all. It is my great pleasure to introduce Dr. Atul Nagpure sir for the today's session of 10 days national level lecture series. He is assistant professor, Department of Chemistry, Rashtrapita Mahatma Gandhi Arts and Science College, Nagpure, District Chandrapur, Gadchiroli University. He received his PhD in novel catalyst organic chemistry from from the CSR National Chemical Laboratory, Pune. He has deep understanding of biomass conversion to fuel and chemicals and extensive experience of teaching and research. He has many national and international research publications and 2 US patent to his credit. He has delivered many invited talks and presented his work in national and international journal. He also got 2 research fellowships. One is in 2013 and another is in 2011 by CSR Indian in Chemistry. Dear participants, please join me in welcoming Dr. Atul Nagpure sir, who is going to talk to us about research methodology for new researchers. Dr. Atul Nagpure sir, please.
Thank you, Dr. Gandhare sir, for your nice words. Firstly, I like to express my sincere thanks to Dr. Gandhare sir for giving me this chance to express my knowledge with you. I also extend my sincere thanks to Jadhav sir, More sir, Dr. Barsagade sir, Dr. Jivani sir, and Dr. Mishram ma'am, and all his team. Now, let me start this lecture. Please confirm, sir, if my screen is visible to you, so I can start my lecture.
Yes, sir, it is visible, sir.
Yeah.
Yes, sir, visible.
So I welcome all of you to 10 days national level lecture series organized by Nabira Mahavidyalaya Katol, and this is the third day. Today I'm going to discuss an important aspect of the research. I'm sure that many of you has done your PhD with excellent work, and most of you are looking for how to do good in a coming future in the area of research. So today's my topic is research methodology for new researcher. Let me start my lecture with one nice quote on chemistry. Life is chemistry. Dilute your sorrow, evaporate your worries, filter your mistake, boil your ego, and you will get the crystal of happiness. My dear friends, life is chemistry and chemistry is life. So when you are looking to start research, I am sure that many of you has a question. What is research? How and from where I can start my research? In what areas I shall start my research? which is the guide, which is the friends, which is the lab I should go, and which are the resources I have to use to carry out my research. And many more questions will be in your mind. I'm sure that all questions I will address after this lecture. Now, let me start. When you are looking for the research, the first thing first comes, you have to dream it. Dream means what? Don't take a sleep in a night and dream that you're going somewhere. Not about dream. Dream means what are the things you're planning. Okay, you choose a specific areas. In a chemical science, we have diverse area. Choose a particular topic. You can start with organic chemistry, material science, analytical chemistry, and so on, and try to finalize them. Then once you finalize that, let's design. What are you planning to do it in a real sense? And the moment you design your work, now the time has come, my dear friends, to deliver it. You need to work in the lab, and after that you may accomplish a research. And the output of that work will in the form of your research article, which can publish in a international research work. The point is, the creativity is fundamental attribute of science, which is driven by the curiosity. Now, many of you are looking for how I can publish my research work in high impact factor. Those who are well known in the research field, they know what is meaning of impact factor. So now let's consider that one person is sitting down the trees and he think that apples has fallen down. Okay, that's what he's thinking. And he is not putting his efforts. He's not asking himself a question, and neither he's asking question to the nature why the apple has fallen down from the trees on the ground. He just observe it. And the moment you observe anything in the research, my dear friends, you left with only a less work, and which can publish in a low impact factor paper, and that work is not seen throughout the world. So what the person is doing, he just observing the phenomena of the nature. The apple was there in the tree and falls down on the ground, does not use his mind. He never asked the question to his own minds, and neither he asked to nature. But the good researcher, what he will do, he will try to question the nature. What is there in the earth which is attracting the apple from the tree, and that's why it's fall on the earth. That means he wanted to ask the question. Firstly, he's asking question to himself, why it is the apple fall. He is also asking the question to the nature, what are the forces are there. That means he's trying to go in the deep of the science. The research is the same thing. You start with A, B, C, D, or you start from any point. The moment you have the analysis mind, that you start a research, you want to keep your eyes, nose, ears, everything open. Sometimes the people knows in the world of chemistry, colors can be a significant aspect to judge the progress of the reactions. The smell, okay, these are the attributes of the good research work. And this is nothing but the Newton, my dear friends, sitting in front of in the down the trees, and he had discovered the law of gravity. The apple falls earlier before the Newton, but why comes the Newton only? He thought that there is something, and he has discovered a new logic, a new concept to the words called law of gravity. And friends, the research is the same thing. You do small work, ask yourself question, why it is happening, how it is happening, and what are the possible reasons for that. So be like a Newton, don't be like a common man in the research. That means the idea which matters. So those who are planning for the research is the process. Already I have told that identify the problem. what is the problem, what is the idea, you're going to work it, and after try to review the literature, people has worked on the same field or not. And if not, this is the good chance for you. And if people already work around the world, you need to review the articles. You need to find out what are the process has been performed so far, what are the disadvantages and how we can overcome that disadvantage. And after that, set your plan, set your objective, and start to work on your hypothesis. Then next, design your process. After that, start working on the design. And the moment you are working, simultaneously you need to record the reading each time. What happened in the laboratory, we do only work and we never take the readings, and we never write down the important aspects of the work. Friends and my dear students, if you're starting a work, writing your research notebook is very, very important, because that is the real aspects of the work. Just a minute, I think there's a power shot, and I'll get try to open the window. I hope that everything is now good. Yeah, there's a power shutdown is here. Yeah, fine. So I'm trying to tell that there is a report writing come first, and then you need to analyze the data. Instead of analyzing data in a rough sense, you need to present your data in a real, in a pictorial manner, in a diagram manner, in a schematic manner as well. And afterwards, you can have a good research work. So if you're starting, these are the aspects, these are the attributes has to be there in your research work. Now, let me share you the adipic acid process, and which is now based on the fossil fuel. All of you will be knowing that the adipic acid is a good platform chemical and can be used for many polymer industry. For your knowledge, the adipic acid is used for polymer industry and can be obtained from crude oil. And from the crude oil, we'll get the benzene, and benzene by process of hydrogenations will get the cyclohexane, and which is on oxidations, you'll get the Ka oil called cyclohexanone and cyclohexanol, which is on nitric acid oxidation, we'll get the adipic acid. Now, question here, if crude oil is finished, we know that we are hugely dependent on fossil fuel like oil, coal, and petroleum compound in order to get the energy and fuels and chemicals. Now, imagine one day that fossil fuels vanished. It can only last for a few decades. What happened with this process? And hence, you need to come up with a new idea that we can use the renewable feedstock like biomass. And we know the biomass is a non-fossilized organic compound obtained from plants and animals. And this biomass can be used to obtain the glucose. So start with the biomass, you'll get the glucose, which is on transformations, you'll get the finally adipic acid. The point I'm trying to tell, it is the idea which is the matter. So those who are looking for the new researcher, you need to find out the disadvantage of the current work. And here the adipic acid has the severe disadvantage because it's completely based upon crude oil feedstock. And therefore, the biomass can be a really good perspective if you wanted to work on adipic acid process. Now, let's imagine that you have start your work and you are analyze the data, and now you are come up with writing a good research articles. Okay. Now, when the idea comes in your own mind, write down somewhere. Maybe you are watching a TV, you are traveling, you are playing, whatever you are doing. the moment your research idea comes into mind, it has to be written in a summary, because we don't know that after some days or sometime it will there or not. So first thing, the moment you got the idea, write down it. Secondly, if you're planning for research work, record your reading and the result. Third, make table and draw the structure and the graphics. For your information, writing in a words add the common practice. But if you're able to express your data in a table manner, in a graphic manner, or you can see in a schematic presentation, that is a real good way for representing your result. Next one, note a significant observations during the synthesis and evaluation. As I discussed already, that your eyes, nose, ear, everything should be open in a chemistry lab. Okay, if you are working in some scheme, and a small thing you need to observe, you to record in your record books. The next, if you feel that there are points which you need to revise it, revise the point. In many cases, it has been observed that the readings are not constant, and if you feel that reading is not constant, you may need to repeat the experiment again in order to validate your work. And at the last, start writing your manuscript. This is the long journey. So if you're starting a research, idea comes, you are working on your project, you apply your hypothesis, you're recording the result, you start making a table, drawing the scheme and the graph, then you are checking and again cross-checking the reading, and finally your draft has to be ready. Now let's look at how the review process is there. So you finally you ready with your manuscript. What you do with your manuscript is a long process. Firstly, if you are ready with your own manuscript, the author has to submit the work in a journal which is well known in the world, like you can say RSC or ACS publications elsewhere, and so on. After that, your article will be forwarded to the journal editor, and he will screen the article. I'm going to say whether your work is good or not. He will first observe it, and afterward, on acceptance by the editor, your work will now send for the peer review person, which is well known in your work area. And after that, the reviewer will assess your work, and if they are assessing your work, they can accept the work or they may reject your work, and if they're accepting work, they may questions the work, that this point has to be there or this point has not be there, or they may tell you to repeat the work as well. Now later, after getting comments from the reviewer, you need to incorporate the changes, and later on you need to again resubmit your work to that journal. If the editor agreed for the changes you have made, he can accept your work. So look at the long process. You design, you work, you have make your manuscript ready, and after that, after submission, you'll get the acceptance, review will send you the work, and finally the work can be accepted. This is a long journey. Now we'll try to look at what are the essential parts of your work. First come first, title has the substantial importance in the research work. it should not be a long, it should not be short, it has to be a concise and appropriate work, which can throw the importance of your work, followed by your author's name and affiliation. Abstract. Abstract is the concise discussion of the work you have done, and many manuscript or many journal has their own rules, and in that section you need to represent your work in a short and but sweet manner. In the part of introduction, you need to give your overview of your work, that what are the problem we are going to address it, what peoples are doing throughout the world, what are their results, and since we have some disadvantage in the work, and therefore we are come with a novel idea, we come with a good concept that can overcome the disadvantage of the current work. And in this introduction part, you have to give a complete summary of your work. And in experimental section, what are the chemicals you have used and what are their grades, how you prepare your material, and what are techniques you have used to characterize that, and what are the process of the evaluation. All this will come in experimental section part. Afterwards, we have results and discussion section. Here, suppose you are working in the material science, and in a material science, you need to characterize your compound by XRD, SEM, or TM, or Raman, TPD, TPR, and so on. So all the characterizations of your material, of your catalyst, will come in this section, and followed by the discussion. If you are carrying out a reaction, you can also optimize the reaction parameters, such as you can optimize the solvent, you can optimize the temperature, and you can go for the pressure study. If you are working on the heterogeneous catalyst, you can also go for the recyclability study, and so on. And if you are able to explain what is the reaction mechanism for particular system or particular design, will give the high impact to your work. Now, next is the conclusion. In this conclusion section, you have to give in a concise manner, so that what are the output of your work and what are the advantages of the current system, and how this process was able to overcome the disadvantage of the current data. And you need to acknowledge the research work. If you are taking help from your friends or your colleagues, or if you have the funding, you need to acknowledge that. And after that, the reference of your work you have cited. Now in this, I have already given one scheme that how the biomass can be useful to replace a current petroleum-based design in order to get fuel, chemicals, and power. Here I'm giving those who are interested in doing a research work in a nano material, as you are aware that how nanomaterials can be a really good aspects for the current, because nanomaterials has find the applications in many areas, in renewable energy, in energy storage, a catalysis. And catalysis now is one of the field in the research has shaken the world by application of nanomaterials, and followed by cosmetics and polymers. The nanomaterials also find these applications in environmental science, agriculture, food, optical engineering, nanotechnology, medicine, and drug delivery. Furthermore, it has the applications in electronics, and nano devices, textile industries, photography, biophysics, defense and security, biochemistry, materials, and metallurgy. So these all are the important aspects and the outcomes of using the nano material. Now, for your knowledge, why the nanomaterials are getting immersed in this current decade? The reason is very simple. If you are looking for the bulk has the completely different characteristics as compared to the nano. You can make the material in the various shape and size. You can go for 1 to 10 nanometer. You can again increase the size, and because of variation in the surface energy of the nano material, its characteristics is a chemical and physical properties also change in a significant manner. And those who are wanted to do the research work try to take nanomaterial is one of the work for the research. Now things here, as I already discussed with you, how to carry out the research. Now the point here, how to start it. Suppose you are starting a research work. Suppose your friend told that you want to do your PhD or your MPhil and so on, and you wanted to carry out the research. So if your friend told that you having A reactant and you have B product, so you taken some solvent, you heat it, you use some material to catalyze the reaction, and you got a compound B. But whenever you are planning for your research work, you need to look at the many aspects. What is A? What is your reactant? And from where you are getting them? It is obtained in the nature, or is it petroleum-based compound? Right? So understanding the source, the properties of the reactant is very, very important. Secondly, what is the product you are looking for? Is it carcinogenic? It is good for your health. Is it good for your environment? Okay, so the physicochemical nature of your reactant product as well as the reagent what you are using is very, very important, because in the point of green chemistry, your reagent, your reactant, your product should follow the principle of the green chemistry. So firstly, the conceptual model is very, very important. You design the process in such a way that there is no hazardous materials are involved, and that should follow mostly the green chemistry principle. Okay, so firstly, design the process which is based upon green chemistry. After that, try to formulate the hypothesis. Whatever you're planning, try to work it. Or say, for example, that you're planning to work in the lab and you don't have facilities. What will do? So planning means if you wanted to design, if you want to test the hypothesis of the work, the first question should you in your mind that can I do that research work in an existing facility? Do I'm having the characterization data, or do I'm having facility in my own lab? If I don't have anything in my lab, how I can start the research? Therefore, design and planning is very, very important aspect in the research work. So if you're planning, try to design the work and carry out the research. As I already told you, analysis, interpretations, and compare the data. In a previous slide, I gave just one example of the common man and the good researcher. You have to analyze your data in a proper manner. Sometimes while analyzing their data, you may miss a key aspect, you may miss key finding. So that should not be there. You have to analyze in a proper manner. Try to compare your result with the existing data. Is it superior or inferior with the current data, and how we can improve? Suppose you are just getting a 20% yield of your product, and still you are claiming that I have did a good research. That is wrong, my friends. So can I improve my yield? Can I increase my stability of the material? How do I can again characterize my material in the proper manner? And for that, you have to analyze your data in a proper way. Many times we come across that whatever the data is given by machine, we accept as it is. Say, for example, you have given one sample for doing XRD analysis or TJ analysis, and you send to some lab from where we used to get the data done. But by mistake, if we send you a wrong data, or if machine is not working in a proper manner, you should have idea, you should have knowledge of that study. Or simply whatever the machine is giving and you put in your work, that is a wrong practice. For that, whatever you are starting, you should have in-depth knowledge of that study. Don't take whatever the machine is giving. You should have knowledge that you can cross question the machine that am I getting a right data or not. In the field of research, many times this has been happened that machine was not doing well. There was not in proper manner, and we are using a same wrong data. So for that, you should have a basic knowledge of that characterization study. Further, the expropriation, generalizations, and prediction. So again, I'm starting with the A reactant and my B product with help of some reagent. Okay. Are you only focusing on getting a yield, or that I'm satisfied that I got 90% of my product? What happened with the 10% of side product? Are you interested? You must interested in what is there, what is the lab. If you are getting 100% compound and there is no side product, this is fine. But the moment you are not getting 100% compound, what is there? Something. Because based upon the analysis, based upon the result, it is sometime will give the clue. Because if you know what are the extra is forming in the reaction process, how I can minimize that and how I can decrease the yield of the side product. Finally, which you should know the applications of the compound. You have dream it, you have design, you have compound. But the question here, where do you use that? Can I use, or shall I simply doing my research work because my guide has told me to convert A to B? My friend has given me an idea to convert A to B. Now, firstly, you should have the thing in mind that what are the applications of the process. And if you don't have any applications like energy storage, like polymer, like textile, and so on, first thing, what are the applications of your desired product? So if you are keeping all these things in your mind, you can plan a good research work. So again, just to conclude my lecture, as I told you, innovations, you should always look for the innovation. Don't do the things which are routine, because we need to get promotions, we need to publish the work, and simply somehow we so-called, I am again putting in the comma, We do so-called research. Dear friends, don't do so-called research. Try to follow the innovation. Try to go for the applications in the current science field. Develop the methods that no one has, imagined so far. Don't be like a common person. Be like a Newton. And if you're developing a method, try to find out the advantage of the process. You can interpret the data in a proper manner, which no one has done so far, and then start to writing a research article. So these are the outcomes of the research field. Now let me conclude my lecture on the research methodology. Don't think that if you are doing research means if you are doing something, new thing. We are just trying to find out the region of the hypothesis which world don't know. So I welcome all of you in the field of research, and I hope that you will carry out your research work in a proper manner. Look for the innovation, look for the green chemistry aspect, look for the applications, and try to solve the issues what we are facing. We are facing a problem of energy, right? We are facing a problem of fossil fuel. We are facing a problem of a storage material. We are looking for a long-term stable catalysis for many chemical transformation. Look for that aspect. Think like a proton and stay positive. With this, I would like to conclude my lecture. I again extend my gratitude to Dr. Nilesh Gandhare sir and his complete team. Thank you for your valid time. Now the class is open for discussion. Now finally, I think light has come. So finally,
Yeah, I must say that if anybody have any question or queries, they can drop the question in the chat box, please. If anybody have any questions regarding the topic of today, so you can drop it in the chat box, please. If anybody, so I will check.
yeah, madam.
I think there was one question.
Yeah, yes, ma'am. Please go ahead.
Just a minute. Sir, I think one of the attendant or one of the participant asked you that what is the impact factor and how one could find the impact factor of any journal.
Yeah.
The question was like that. Yeah.
So if you are looking for impact factor, a best practice is to just to go to the Google and type the name of research article and go to the home page. In that, you'll get the every information about that research article, including impact factor, editor, template, author's guideline, and so on. Moreover, each publishing house has their own Wikipedia. Suppose if you are looking for green chemistry or LCL paper, every publishing house they has their own list of research articles, and you can get the information of the impact factor and how it is changing. Okay, and impact factor is nothing but a quality of the work. So those who are asking the question, please refer the homepage of that particular research article. You'll get the each information regarding that.
Sir, there were no questions in the chat box. So thank you very much for your valuable insights into your topic, that is research methodology for new researchers. It will hopefully help all the participants in their future while they think for the research or when they think for their projects in future. Thank you very much, sir. Now, the next one is the.
Ma'am, actually, there is some questions, so I can if
Yeah.
so I can read it. There is a Swapnil Tale, sir is asking that, sir, how I can go for computational chemistry work? So,
Yeah.
so if you have time, I would like to answer the question.
Yeah, you can, sir, you can.
Yeah. So, computational chemistry, computational research work is a field of, theoretical science. Theoretical science is based upon density functional theory. This is called DFT theory. Whenever a particular reactions occur, say, for example, you have copper catalyst, and copper catalyst you use for one chemical transformation. So as a experimental chemist, we perform the reaction in the lab. We'll find out the outcome, and what computational chemist will do. Computational chemist will give a theoretical data, like if you have copper plane or copper particle that your reactant is observing on 111 plane of copper, or it is getting absorbed on 100 plane or on 200 plane, and what are the energy barrier. Okay, so if you are looking for the computational chemistry, you are basically trying to find out the energy barrier, and we are trying to discuss the absorption method by the theory is called as a density functional theory. In that, we no need to do a work in the lab, but with the help of software, still we can find out the answer of the questions, right? What is the temperature you need to give for particular reaction? What will be the amount of pressure, like oxygen or hydrogen gas? Which special catalyst or which metal you have to use, and what are the reaction conditions in order to maintain to optimize your yield of the process. So this is nothing but a theoretical work.
There is one more question from Manjeet Singh, that how we give references in
Yeah. So I can read the question from Manoj Singh. He's asking, sir, how we give references in bibliography. So the simple softwares we have software like EndNote. EndNote, like softwares are there, which you no need to put extra efforts, and that software will help you for the referencing pattern. Not only the EndNotes, there are many softwares are available, and those who don't have time to make a template and transfer that, many softwares which are paid, which can directly transfer your manuscript from the Word to the template. It can be RSC, ACS, elsewhere, and so on, and they will manage every aspect. So no need to worry about writing and putting your drafting your articles in that particular journal as well. Their softwares are there, mostly are paid software. Yeah,
there is one more question, sir,
yeah.
from J. Vijita. She wants to ask you, sir, please explain quantum studies.
Means, is she asking in a theoretical manner, or
Only she wrote that explain quantum studies, sir. Yeah.
fine. Now, say in a quantum study or quantum mechanics, we are looking for the particles. Say I'm holding my mobile. Okay, once I have the object, or if I have the system which is a bulk, which is a macroscopic in a nature. For macroscopic system, we always go for classical mechanics. But there are particles which can travel with the speed of the light. For that, you have to look for the quantum mechanics, because a classical mechanics get failed. So in a quantum mechanics, we are looking for the energy aspect. That suppose you are having electron, say for example in atom, and a person is standing behind the atom. Say, just for example, you have, say, you have atom, and you are not in the atom, and you are outside the atom. I hope that you are getting the point. We have atom, and you are outside the atom. Now, in the quantum mechanics approach, what we look, we will try to see what is the chemical entities are there in that atom. How far I have to travel from that distance to the atom in order to see the electron, or in order to locate the electron. And in that direction, is the electron is moving. And what is the energy criteria for that? In a quantum mechanics, we will look to the object in a quantum mechanical way, and there are the system, or there the postulates, like we can say H operator, or energy operators, or positions operator, that you need to apply if you wanted to understand the quantum chemistry. I think we don't have much time to explain on that. Or best way, those who ask the question, they can talk to me personally.
Sir, sorry to interrupt you. There is one more. Actually, Manjit Singh again wants to ask you that give information about plagiarism. And Swapnil Tale want to ask you, sir, suggest guide for computational chemistry work if you can.
Yeah.
He wants to suggest you one guide. Yeah.
So there is a one well-known guide, I should say, scientist, which was a former director of National Chemical Laboratory, Pune, and his name is Professor Saurabh Pal. This is the one of the best scientists India has produced so far in the field of theoretical science, and in the computational chemistry. It's called Professor Saurabh Pal. He was the former director of National Chemical Laboratory, Pune. I think, in my knowledge, currently he is also director in the West Bengal some CSR lab. So you can search on the Google Professor Saurabh Pal. You will get the many article. He's a well-known scientist in the field of computational chemistry. I think second question, something I think he asked me, how
Plagiarism, and if there any software for the plagiarism.
Yeah. So if you want to check the plagiarism, the Authenticate software is there, which is a well-known software. We can check a plagiarism. The one thing you should know that don't go for the free software which is offered by Google. They are not proper, because the free software are only has the low input data, and if they are saying you don't have plagiarism, they have low data, and hence they are giving less value of your similarity index. So if you wanted to go plagiarism, try to access for the authenticate software. Don't depend only on the free software which is available on the Google. Okay, they are not completely, because they have less data input there. Yeah, I'll be happy to again add some question.
No, sir, there were no questions. Thank you so much, sir. Now, I would like to call upon Mr. Nilesh Zadav, Assistant Professor, Department of Chemistry, Nabira Mahavidyalaya, Katol, to propose a vote of thanks. Zadav, sir, please.
Thank you, madam. Am I audible?
Yes, sir, yes.
Okay. Good afternoon, one and all. I would like to thank Dr. Atul Nagpure, sir, from bottom of my heart for giving his valuable time and delivering such a motivational, wonderful lecture on research methodology for new researchers. Truly, sir, all the participants surely got an idea about research methodology for new researchers. Also, I would like to thank Dr. Gandhare sir for nice introduction of guest speaker, Dr. Meshra madam for comparing the session, Mr. More sir and Dr. Jivani sir for their technical support. Lastly, I would like to thank all the participants for participating and listening carefully with a great enthusiasm. With the permission of organizing committee, I would like to conclude here that today's session is over. We will meet tomorrow with our new guest speaker. Take care. Thank you, all of you. Over to you, madam.
Thank you, sir. Thank you so much, everyone. And we will meet on the same platform with a new guest speaker tomorrow at 12:30 sharp. Thank you so much. Thank you, sir.
Ma'am, thank you very much. See you in a offline mode very soon.
Yeah, why not? Why not? Sure, sure.
Nice session,
Thank
sir.
you, sir.
Yeah, thank you, sir. Thank you, sir.